Today we are going to study about the correlation analysis. Now we know what are the basics of statistic and scales of the measurement and the data type. So according to those features we can classify the correlation analysis also. Let's see how it happens. Okay, first of all I like to define the correlation. Correlation is a statistical tool which studies the relationship between two variables under study. Correlation analysis involves various methods and techniques. The studying and measuring the extent of the relationship between the two variables. If there is any relation between two variables, when one variable change, the other also change in the same or in the opposite direction. So the major function of correlation is saying the strength of the relationship. They are not explaining the form. They are only saying what is the strength if there is a relationship in between those two variables. Here only we consider only two variables, and here we are saying only the strength. We are not saying about what is the form, what is the origin and where it started and where it ends. We are not to speak about those, but we say what is the strength. It means the study of existing magnitude and direction of the relation between two or more variables. The famous astronomist Braves, Professor Francis Galton, Carl Pearson, Professor Neighbor, and so many others have contributed to this great subject. So as the honor for those people, we should remember them. So let's see what are the correlation assumptions. Before you can compute the Pearson relationship, make sure that following assumptions are satisfied. Even though we discussed the general term correlation coefficient, here we are going to construct some linear type relationship under the Pearson method. Then today video I discussed about two types. Then those are about Pearson and Spearmint. So now you are familiar with scales of measurement. If you are not familiar with those concepts, you can go to my scales of measurement video. Then under that you know what mean by the interval and ratio. So under the Pearson regression we can consider only about the scales of measurement which the variable which are coming under the scales of measurement, interval and ratio. We cannot take nominal and ordinal to calculations of Pearson regression model. If you are using some statistical software and if you are directly apply the correlation, normally most probably they are offering the Pearson R. Normally we use R term for that. They are providing the R value for you, but you should know what are the types of data you are using. So that's why we all at my very first video we said that the difference in the statistic than the mathematics is the thinking. Here we add our thoughts. So we should make sure that we are applying the correct data type. Okay, then distribution of the variable is normal. Why we are assuming that variables are in the normal distribution? We consider to have a good power in the statistical test, we should use random variables. So to prove that randomness, we observe that should be distributed in a normal distribution. So distribution is continuous. Okay, under these four assumptions we can move. If we are satisfied with these four, we can move for the calculations of Pearson's R coefficient. There are some another important concept. A correlation is a relationship between two events where a change in one event implies a change in another event. That's why we are using two. Correlation doesn't mean that a change in first event causes a change in the other event. That's not the mean, but we are meaning in this way. That will imply, but that is not the cause. So you need to understand about these two, implies and cause. The strength of a linear correlation can be measured using a correlation coefficient. The strength, I stated that very early, strength. We are considering the strength in a linear correlation through the correlation coefficient. Before determining the correlation coefficient, look at the scatter plot of the data and make an initial assessment of the strength of linear relationship between two events. Normally, as the first step in the correlation analysis, we should use a scatter plot. Then we can quantify by using some correlation technique, the formulas, what is the value. Okay. Here there is another classification. This is relates with the scales of measurement. You can see in the first line 4 scales of measurement are noted. Under the parametric test, if I say the heading, difference between parametric and nonparametric test. So what is the difference between parametric and nonparametric in the case of correlation analysis? So parametric listed out in the first column and the nonparametric listed out in the second column. And the first point, they speak about the scales of measurement used for ratio and interval data. We use parametric test. If I state the names, Carl Pearson's method we use for the parametric, Spearmint method we use for nonparametric in the correlation case. So for ordinal and nominal, we use that one. Use normal distribution in parametric test. It will powerful with the normal distribution. In the nonparametric, we did not take any distribution. So we use another term for nonparametric called distributionless method. So mean is usually central measure, median is usually central measure. Information about population is completely known, no information available. Specific assumptions made regarding population, we are using some assumptions. We have already discussed what are those in correlation case, but in the nonparametric we do not use any assumption. So we called it as assumption free test also. So here I told you 3 terms for the nonparametric test. Nonparametric test, distributionless methods and assumptionless or assumption free method. Say it as the distribution free methods and assumptions free methods. But we consider all things under the parametric. That's why parametric tests are more powerful than the nonparametric test. Okay. I told you that as the first step we are taking a scatter plot. So here there are 6 graphs. Let's move to the first one. So according to that distribution of plots, if we draw a general line that is coming in this way. So what it says, this is the A on x-axis and B on y. So that says the movement of the increases of value of A, then parallel to that B also increase. Then if I consider about this point, these are the 2 values for the A and B. If I shift for here, the value of A has increased and the value of B also has increased. So we can say there is a plus increment in both axes. So we can say those two are positively behave. Let's move to the second one. Then negative correlation. That's about negative correlation. Then what it say? They are changing into opposite sides. So the increase of A make a decrease of B. Let's see this point. The value of A is less, B is higher. So if I come into here, A has increased but the value of B has decreased. So we can understand that they are behaving in the opposite way in the second graph. Then the third graph, it's about no correlation. How do we say so? Then if we draw a line, if we cannot draw a line clearly, then there is no any pattern, clearly identify pattern. So we can assume that these are distribute with the parallel to the line is distributing parallel to the horizontal axis. So in that case, we called it as no correlation in between these two variables. But the major thing is we cannot identify any pattern. So there should be a pattern if there is any relationship. So if they are not in that way, we say it as a no correlation. Okay, let's move to the fourth one. Then it's about the fourth one and fifth one. It's about a strong and weaker concepts. So if we draw a general line, then our plots are so closer to that line, we can say generally it's a strong correlation. Then if our plots are somewhat far away from the general line, we can say it's not a strong relationship. So we can say it as a weaker correlation. So if we can see any curvy pattern that may be in this way, and if in this way or in that way, likewise if there was any curvy pattern, we can say it's a non-linear correlation. That's why I stated very early about the linear concept. Here we are considering only about linear things. Then linear means it's a straight behavior, not a curve one. Then if we have this kind of a pattern, that's not about linear correlation. So we have to use some another techniques to consider about that. Okay, these are the general equations which we can use to calculate the correlation coefficient. So as I mentioned in graph, that was A and B. Here I have used the X and Y because X and Y is most probably we are using in the formulas. Okay, then there are two methods. You can use any method. By using this anyone, we can have the similar answer. So here it's a multiplication of X and Y. Then finally take the whole summation of all terms. It's summation of X, summation of Y. N is about the population, all observation amount, and here it's about the summation of X square values. So we should take the first square value of X, then finally we take the summation. Then here it's about the square value of summation of X. So we need to solve the term inside of the bracket first. So what we should do first? We should take the summation of X. Then we have to take the square value of that one and divide it by the n. Likewise in here. Here also it's somewhat in that way. Here they are taking the multiplication of that one. So it's somewhat different method, but you can solve these two. Okay, here I have given the definitions for these all terms. You can refer that one also. Okay, here you have an example. Now you can try. Consider this about X and Y. You can use anyone in your way. Then you can simplify this one and calculate what is the value of that one. Then the value is coming as 0.975724 according to my calculation. So you can check whether you can solve it or not. If you fail to take it in first time, you can try it again and again. Then I will teach you how to get calculation by using SPSS software. Then you can cross check by using your statistical package, and you can try the correct answer, take from that path also. Then you can cross check, always you can cross check your manual calculation tally with your software or not. Okay, if you use an Excel sheet, you can easily calculate these things. First, you may plot your first variable and second variable, then take the multiplication of these two. Then again take the square value of first variable and square value of second variable. Then after taking the functions summation, you can take the summation of these all. Then you can simply add these values into the formula. Okay, that's all about the Pearson correlation. Here I am going to present you about the Spearmint correlation. Then what I mean by the Spearmint correlation is designed to measure the relationship between variables measured on ordinal scale of measurement. Similar to the Pearson correlation, however, it uses ranks as opposed to actual values. So let's see how it comes. Alternative name for the Spearmint rank correlation is braid correlation or the rank of observed in replaced by the braid. When x and y are perfectly monotonically related, the Spearmint correlation coefficient becomes 1. The perfect monotonous increase relationship implies that for any two pair of data values, we can say it in this way, is always have the same. Okay, this is the way of getting calculations for that one. Let's see in this next slide how it will come. Then here there are row. Spearmint row is the mark of that one. In the Spearmint case we use R. In the Spearmint case we use row. Then D. We need to extract the D from our data set and the N. N is number of observations. Okay, suppose that I have ranked my ordinal data set in here. Then adjusted rank. What mean by that? Then suppose that if we have same rank for 2, we have to take those 2 into adjusted rank. Okay, then in next thing we need to take the difference. Difference mean from then if you see the rank 1, here rank 1 and rank 2 about 2 variables. If you consider about rank 1, there is no any repeated observation. They are taking various values. But in the second case, there were 2 values in the row data set. So the 6th place has come. So we have to make an adjustment for that one. Okay, it's about after taking the adjustments, it has taken as the 5.5. Then we need to take the D. D is about what? D is the difference between rank 1 and rank 2. Then after we are taking adjustments, we have to use the adjusted value in here. Then okay, then how I couldn't explain how this 5.5 has come. Then you can see 1, 2, 3, 4, 5 is not here. So 6 is here, 7, 8, 9. So the missing point is 5th one. So they are having the 5 and 6 as the 6th place. So we have to take the 5 plus 6. Those are their places, 5th place and 6th place. So 5th and 6th plus, then summation of 5th and 6th is 11. 11 divided by 2, it's 5.5. That's the way of taking that value. So we need to take the difference. Now we are in the third step. That's the taking the difference. So difference is we need to take the adjusted variable and the other rank. We are taking the differences. So difference between 3 minus 5.5 is minus 2.5. Likewise we are taking. Then we take the squared value of D. Squared value of D. Then finally we are taking the summation of that one. So now we can add this value into the row function 6 times this value minus something blah blah. You can have the okay. Then I did not add a slide to how to interpret those values. Now I am going to virtually present it. Normally correlations value are taken minus 1 to plus 1. That's the range of correlation coefficient values. So it's minus 1 is representing the perfect negative correlation. Plus 1 represent perfect positive correlation. So number 0 represent the no correlation, and the minus 1 to 0 express about the idea about minus correlations. From 0 to 1 plus 1 positive 1 explain the degree of their correlation relationship in positive method. So that is the way of interpreting the correlation coefficient. So I will do another video to teach you how to use SPSS to take these analysis. So you can use the functions and you can use the Excels also. So this is the end of today's video.